Hi, welcome to Essential IT and Security Skills. I'm Charles Redmond, Master Trader, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. The serial ATA interface, or the SATA interface, solved all those problems. It uses small, narrow cables which allowed for better airflow, and all SATA drives are hot swappable, with an increased maximum throughput of up to 600 megabytes. With the introduction of Windows Vista and Windows 7, it introduced the ARECy, or the Advanced Host Controller Interface. It's an extremely efficient way to work with SATA HBAs, and it makes hot swapping work much better. However, if you're going to be using a SATA drive, you need to implement the ARECy and CMOS before installing the operating system. So SATA drives come in two basic flavors, SATA 1.5 gigabyte and SATA 3 gigabyte drives. Sometimes you'll see the SATA 3 gigabyte drive indicated as SATA 2. Next, we have eSATA, or external SATA. It extends the SATA bus to external drives. Theoretically, they have transfer speeds up to about 6 gigabytes, but in today's USB 3.0s, you max out right around 5. Here's a look at an eSATA connector on the back of a motherboard, or you might have what was referred to as an eSATA Express card. Next, let's talk about the Small Computer System Interface, or SCSI. SCSI's been around since the 1970s. Historically, you needed SCSI drives to implement a RAID. However, today we're seeing SCSI by and large being replaced by the SATA drives. SCSI drives are implemented in what's called a SCSI chain, and they all work together through a host adapter. That host adapter is a device that attaches the SCSI chain to the PC. And all SCSI devices are divided into internal and external groups. Many texts have referred to the host adapter as the SCSI controller, so you should be comfortable with both terms. So since you're required to have the two groups, internal and external, you need to understand what they do. So the internal SCSI devices are attached inside the PC and connected to the host adapter through the internal connector. External devices hook to the internal connector of the host adapter. Internal devices use a 68-pin ribbon cable. You see one of those below. External devices may have two connections on the back to allow for daisy chaining. A standard SCSI chain can connect 15 devices plus the host adapter. So how do you know which SCSI drive is which? Each SCSI device must have a unique SCSI ID. The values range from 0 to 15. However, keep in mind that no two devices connected to a single host adapter can share the same ID number. You'll set the SCSI ID by configuring jumpers, switches, or possibly even dials. To do this, you're going to need to brush off your binary skills. For instance, device 1, or ID 1, 0001, or off, 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 on, all the way up to device 15, or ID 15, 1111, or on, on. So at the end of your SCSI chain, you need to be sure to terminate. Termination is used to prevent a signal reflection that can corrupt the overall signal. However, most of today's manufacturers build SCSI devices that will self-terminate. Next, let's talk about RAID. So the most important part of a PC isn't the hardware itself, it's the data that it holds. Building in fault tolerance by implementing a RAID is a way to offset and protect the data. There are several levels of RAID that you will need to be familiar with. Starting with RAID 0. RAID 0 offers disk striping. It writes data across multiple drives at once, and it requires at least 2 hard drives. However, RAID 0 is not fault tolerant. So if any drive fails, the data is lost. RAID 1 introduces mirroring or duplexing. It's the process of writing the same data on 2 drives at the same time. It also requires at minimum 2 drives, and it produces an exact mirror or duplicate of the primary drive. RAID levels 2 and 4 are very rarely, if ever, used. However, the A+ certification expects you to know the basics of RAID 2 and 4. They are, with RAID 2, you have disk striping with multiple parity drives, again, not used very often, and RAID 3 and 4 gives you disk striping with dedicated parity. All were quickly replaced by RAID 5. RAID 5 offers disk striping with distributed parity. It distributes data and parity evenly across all drives. To implement RAID 5, it requires at least 3 hard drives. This is the most common RAID implementation today. To implement a RAID, you'll either use SCSI, which has been the primary choice in the past, or SATA, which is commonly used today. You'll also have your choice of whether to implement a hardware or software RAID. With a hardware RAID, you'll have a dedicated controller, versus a software RAID where the operating system recognizes all the individual disks. With a hardware-based RAID implementation, it's invisible to the operating system and is configured in several ways depending on the specific chips involved. Most RAID systems have a special configuration utility in the flash ROM. You access these after CMOS, but before the iOS loads. With the advancement in hard drive and RAID technologies, an ATA RAID controller chip has gone way down in price, so it's somewhat common to have a personal RAID in your own home. So now that you understand hard drives and the different hard drive technologies, let's work on installing these drives. So first, choose the drive that you want, either PATA, SATA, or SCSI. Be sure to check the BIOS and motherboard to see which hard drives are supported. Next, set your jumper and proper cabling, whether it be a master drive or slave drive. And then connect it. If you're using a PATA hard drive, you're going to need a ribbon cable, pin 1 to pin 1, and a Molex connector for power. If you've chosen a SATA drive, the SATA cable itself is keyed, so it only goes in one way. Here's a picture of a SATA connector, and you see a separate Molex for power. To connect a solid-state drive, most commonly found in portable PCs, you're going to connect it the same way as the older hard disk drives, whether PATA or SATA. However, you will need special drivers if you're going to install a solid-state drive in Windows XP. To connect a SCSI drive, first you need to find a compatible controller. Next, connect the data cable. Just like the PATA drives, pin 1 to pin 1. This is very important because reversing the cable can damage the drive or data or both. Then, using the Molex connector, connect the power and configure your SCSI ID. Next, let's take a quick look at configuring CMOS. Here you see the typical controller settings in CMOS and the option to enable ARECi. Remember, if you're going to use ARECi, it must be configured prior to installation of the operating system. Next, you need to identify the boot order. This is to tell the computer where to try to load the operating system. So what do you do when you run into problems? Well, if auto detect fails, you might want to check the power. Or if you're using a PATA drive, check that the ribbon cable is installed properly and seated properly. Or quite possibly, you've set the jumpers wrong. So if all the physical settings are correct and you're still running into problems, then you need to take a look at some possible CMOS errors. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.